function. The true excitation frequency is, let's say, some omega. If the true excitation frequency is capital omega, rho 1 should become singular or infinite at capital omega, whereas chi naught becomes singular at omega ij. So now idea is solve this equation somehow or the other and get capital omega out. Is the motivation clear?
So NI and J are the occupation numbers.
That's it. So Ni has to be occupied and T has to be unoccupied. If both are occupied, it will not give you. If both are. So perturbation takes it from occupied to unoccupied. First order perturbation. Now at omega, rho 1 r omega goes to infinity, right? Phi 0 r prime omega finite. So is V1 and V is finite. So this term is infinite, this term is finite, and this would be infinite again. Right? So I use that fact to pull out things. Let's see how we do that. So I'm going to write rho 1 omega is equal to, since this is, I'm close to omega equals omega, I can neglect this term. Okay, this is infinite. So I'm going to write this as integration dx, integration dx prime, then I have 1 over x minus x prime plus fxc x prime omega close to capital omega, right? And then I have rho 1, so I'm going to insert some function, complete set, zeta x prime omega, zeta x double prime omega, index I, summed over I, rho 1 x, the x or x prime. Let's see. Here, this has to be x prime. So this I can write as x double prime dx, where summation zeta I x prime omega zeta I x double prime omega is delta x prime minus x double prime. I am going to use a complete set. Is that okay? Fine. Okay. I'm doing this with a purpose. And the purpose is as follows. Zeta is a set of functions which are complete set. And I'll show you in a minute.
Not wave functions.
Not wave functions.
Just complete set.
Yes. Some complete set. And you'll see in a minute what it is. So I can write this whole thing as rho 1 r omega equals integration dx integration dx prime, right? 1 over mod x minus x prime plus fxc xx prime omega zeta I x prime omega integration dx double prime, or this should be star, one I'll put as star, rho 1 x double prime omega. Is that okay? Now I have taken this thing out. There is a zeta x prime. Now you see, this goes to infinity. This goes to infinity, right? So this implies that at omega equals capital omega, I should have let's write this equation. Integration dx prime 1 over x minus x prime plus fxc x prime omega zeta x prime omega I is equal to some function lambda omega zeta I x prime omega. Let me write this eigenvalue function. So you are asking what is zeta? Zeta are the eigenfunctions for this. And I should have this with lambda capital omega equals 1. If I have lambda capital omega equals 1, I get that rho 1 r omega equals rho 1 r omega. X prime I'm integrating over. There's an r somewhere missing. Just 1 second. It should be, oh, this is x. X also I've integrated. There should be some r somewhere which I'm missing. Just 1 second. The last one was the zeta. Rho 1 was x double prime. That's fine. X double prime, and then I have this x double prime. Where is the r? There's an r somewhere missing. Here is the r. This is rho r. Somewhere I missed an r somewhere. There's a chi naught. Chi naught. R x omega. That is what I see. There chi naught r x omega. So this will be a function of. There was a chi naught here. I missed that. Well, it's transferring the equation, there was a chi naught floating around here. Okay? So if I solve this eigenvalue equation, this is regular equation, right? I can solve it through any method. I can write this as a expansion in some thing, and then some basis set and calculate all the eigenvalues. And as a function of omega, wherever that is 1, I'll get the corresponding frequency. All I'm doing is linear response, just doing it properly checked. And just I'll write one more. I'll just do a single pole approximation, then we are done for today. Now what I'm going to do is, from here, I can write lambda omega is equal to integration dr, integration dx, integration dx prime, chi naught r x omega, right? And all this times zeta x prime omega, and here I can write zeta star x, and this is r. So r. I multiply by zeta, okay? And then lambda omega comes up with this. Is that okay? Now I'll make a single pole approximation. As if there is only one x excitation frequency that exists, there is only one zeta that exists, so that zeta star r omega zeta x prime omega is equal to delta r minus x prime. This is assumed. This is a very crude approximation, but nonetheless,